Yeah, absolutely. I think especially for microplastic science, that's definitely the case. I think there's still some debate between the science community on what is considered a microplastic and what is considered a nanoplastic. And it sounds silly because we're talking about nanometers and centimeters, and it's a super small scale, but it makes a huge difference in the detection of that substance in the environment and how it's affecting all of the animals in the environment. So a lot of our partners are working with different technologies and different protocols to try to detect and sample and measure the quantities of microplastics in the ocean. But you're right, there's not a consensus. I think the marine debris program's kind of way of contributing to the measurement and assessment is our citizen science program, which is called the Marine Debris Monitoring and Assessment Project. We call it MDMAP for short. And it's a way that engages partner organizations and volunteers in completing shoreline marine debris surveys. So it's meant to answer some questions like, how big is the debris that you're finding and how is it changing over time, and what types of debris are the most common? So we're focusing with that project on plastics and other debris that's larger than 2.5 centimeters, just given the complications with the microplastic research. But we are hoping that it will kind of show us how the marine debris problem is changing and evolving over time so that we can best tailor our solutions to what the current situation is.
Yeah. Yeah, I'm happy to say that we've also become a partner with you on that project. And we're conducting monthly coastal cleanups at Future Frogmen, and we're quantifying the data, sorting it and quantifying it and submitting it to your national database. So we're very excited about that and happy to be part of it.
Yeah, thank you. We're happy to have the data, so awesome.
And Demi, one other thing, I'm not sure if this falls into your work, but another thing we heard, perhaps you could comment on it, is that there seem to be a lot of studies in like the top meter of the sea, as far as the, going 1 meter down, and then all the way down to the sediment, the studies on the sediment, but the in between there, though, the entire water column, there seemed to be a lack of research and understanding. Any comments on that?
Yeah, it's definitely the case. I think that, understanding microplastics, how they move and change, how they are leaching or sorbing chemicals, what happens when they're ingested and egested, where they're found in the water column and how to sample them there is all still valid questions that science is working to answer.
One of the things, there's a few topics there, but one of the things, for argument's sake, would be assessment of commercial seafood.
Right, definitely. So the marine debris program, we do have a science team, and we do have a call for research proposals every other year. So a lot of the work that we do is helping to get grant money out to our partners who are doing removal, research, or prevention work. So we do have a call for research proposals every other year. And right now, our priorities are impacts to commercial seafood, freight and transport of marine debris, habitat and economic impacts, and also monitoring, like we were talking about, to learn more about the types and quantities of debris that's present in these ecosystems.
Could we elaborate on those a bit? Like, talk about commercial seafood, for example?
Sure. So that's a great example because both of the funded research partners that we have in this region, in the New England region, are working on microplastics ingestion by bivalves. So we have funded partners at Yukon and at Woods Hole. And our Yukon partners are looking at oysters and how they're taking up both plastic pellets, like small, hard, rigid microplastic pellets, and also plastic fibers. So microfibers is another kind of emerging topic. Of course, our clothing is not made of 100% natural materials. They're synthetic as well. And just normal wear and washing is shedding those microfibers into the environment. And we don't have kind of the proper filters on our washing machines that would capture those fibers. So actually the largest quantity of microplastic pollution in the ocean is microfibers. So they're looking at both rigid microplastic pellets and these synthetic microfibers, and kind of watching with an endoscope. It's really cool to watch their videos, the oysters taking up these plastic particles and seeing if they reject them or if they ingest them, and if they ingest them, how long they remain in their body. Part of what the science is trying to understand is how different animals are going to be affected, and if the duration of time that the plastic remains in the body is a factor on whether it can affect their reproduction or the way that they eat and feed and live. So we're thinking, I think the science is kind of pointing to the fact that bivalves are pretty good at eliminating microplastics from their body. They can spit them out in pseudofeces pretty well, whereas maybe another species like seabirds are ingesting that and then they're kind of feeding it to their chicks. So that could be a more serious situation, but I don't think we can make any claims for sure about who has harsher impacts yet. I think we're still getting there.
Thanks for watching. For more information, visit our website at www.futurefrogmen.org.